Okay, so lesson 2 is about alkanes. So hopefully you're familiar with CnH2n plus 2 already, general formula for alkanes. Alkanes and cycloalkanes are saturated compounds. So saturated just means that there are only single bonds, no carbon-carbon double bonds like this, or triple bonds like that. Okay, I think that the first part is fairly easy to understand, so I'm just going to let you read through that yourself. Recall the structural and molecular formula for alkanes with up to 6 carbons. Okay, so you should be able to draw any alkane with 6 or fewer carbons. I feel like you could, once you know how to draw them, you can draw any number really. So read through that on your own and let me know if there's any issue with anything there. Homologous series is a definition you need to know. Could be up to 3 marks, so you need to have 3 of those memorized. Alkanes are saturated because they have only single bonds, so we need to know that as well. Demonstrate an understanding that alkane fuels are obtained from fractional distillation, fracking, and reforming of crude oil. So we're going to go through each of those different sections, starting with fractional distillation. Fractional distillation is how we initially separate things that we get from crude oil. So we dig crude oil up from the ground, it's full of all sorts of hydrocarbons, it's a mixture of hydrocarbons. So we start to separate them initially by fractional distillation, and then cracking and reforming is how we turn them into more useful products. Okay, so in order to get the products we want out of crude oil, we start by splitting them up by size, and then we start to turn them into more useful molecules using cracking and reforming. All right, so I should have that here, lovely. Fractional distillation. Now you should know what distillation is. Fractional distillation, again, this is all from CCEA, GCSE. Fractional distillation is you put everything into a column, first of all, into a hot column where everything becomes a gas, and then you separate the compounds based on their boiling points. So you throw in your mixture all sorts of different hydrocarbons here, some very large with very high melting points and boiling points, and some which are much smaller and have much lower boiling points. So bitumen is actually even at 350 degrees. So when they go into the hottest part of this fractional distillation column, the bitumen is still liquid, so it sinks to the bottom. So the bitumen sinks and condenses at the bottom as a liquid, or remains as a liquid, and you just remove that through a tap at the bottom of the distillation chamber. So that's how you separate the bitumen from the rest of the fractions, the rest of the molecules. Now, none of these fractions are made up entirely of one molecule. This refinery gases, for example, could be methane, ethane, propane, and butane. Then you have, from 5 carbon molecules to 8 carbon molecules, from 9 carbons to, 12, 13 carbons. So the chains are getting longer, the molecules are getting bigger each time, but they're not split up into individual molecules. Okay, so it's just grouping them by their size or by their boiling point, because the bigger molecules have high boiling points. Bitumen, I think, is carbons above 80. So a chain 80 carbons long. And that has such a high boiling point that it doesn't boil at 350 degrees. So it's removed from the bottom here. Then you can basically give everything an option at each stage. So either it can become a liquid here and then get removed like bitumen, or it can be a gas still. So it's a gas at 350 degrees, it'll rise up the column into the next section. And the next section of the column will be a little bit cooler. So because this is a little bit cooler, suddenly diesel can become a liquid. So the diesel can be removed then as it becomes a liquid. then the things that are still gases at this temperature rise up the column into the next section. So they rise up the column as gases, and then at this temperature, kerosene can be removed as a liquid, so kerosene will condense. Naphtha, petrol, and refinery gases are all still gases, so they continue to rise up the column. This is cool enough now for naphtha to become liquid, so it can be removed because it's easy to separate liquids and solids. Then you have petrol, then you have refinery gases. So as they continue to cool it, they can continue to take things out from the column so that everything goes in here and it all gets separated into one of these fractions. So the last thing to come out are the things that are still gas at room temperature, 25 degrees, and those are your refinery gases like methane. Okay, and that is where you get all of those fractions from. So you do need to know their uses. You do need to know what the different fractions are called. I learned it when I was doing my GCSEs. I just remembered Ripnik job because I couldn't think of a good mnemonic for it, and I haven't seen one since. Although it depends. There can be different names for this. Sometimes that's called petroleum, or I'm trying to think. Sometimes that's called heavy oil or lubricating oil. But I think this is the CCEA website. So Ripnik job, refinery gases, petrol, naphtha, kerosene, diesel, oil, bitumen. So call it heavy oil or fuel oil. So hopefully that makes sense. Let's see where we are from here. So useful products from crude oil. Crude oil is a fossil fuel, so it's dug up from the ground, formed from a decay of sea creatures over millions of years. It's a complex mixture of hydrocarbons containing mainly alkanes, and it cannot be used directly because there's too much in there. It's a mixture of too many different things. But you can use the products once you start to separate them, and you'll notice most of it is for heating and fuel. So, and you know that already. Fractional distillation crude oil is heated and passed into a fractionating tower, separating it into fractions. So they're not pure. So there's C1 to C4, C4 to C10, etc. So they get separated based on their boiling points, and things with more carbons have more boiling points.